Hi everyone, we want to go over a couple quick examples, but these are assuming you've already watched the lessons. These are a couple examples of solving for an angle or solving for a side in trigonometry. If we take a right triangle, I will do the angles, solving for a side first. So let's pretend that's 33 degrees. We have a right angle. We could put an X here, put 100 here. So the first thing we do is we need to label, and then when we label, we'll have to decide whether we're going to use SO, CA, or TOA. Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So I will label my reference angle or person here. My hypotenuse is here. Opposite of the reference angle would be there. And the adjacent's not marked, it's left over. In case you didn't know how I found the hypotenuse, it's across from the 90-degree angle. So now that we have all three labeled, but two of them are being used, we have the opposite and the hypotenuse, O and H. So we must use sine, because sine is using the opposite and the hypotenuse. So we're going to use sine of the angle. Whenever we write sine or cosine, we'll write sine of x or sine of 33. That's the angle. So in this case, x would be a missing angle. In this case, the angle would be 33 degrees. So we have our angle. We're going to say sine of 33 degrees is equal to the ratio opposite, which is x, over hypotenuse, which is 100. So the first step is the setup. The second step, I'm going to replace the sine value with an actual decimal. So if we take our calculator, we're going to write it exactly like it's written. Well, a little bit backwards. When you enter, you put the number first, 33, then click sine. Inverse sine is when you're looking for a missing angle. So we're going to write it the way we have it written here in our notes, sine. So 5446. So really, this is the value of 5446. So now that we did that, we can put a 1 underneath and cross multiply. And the point of that is to get x by itself. So if I multiply this way, I get x. Or 1x. If I multiply crisscross the other way, I get 0.5446 times 100. 100 is 2 decimal places away, so really we don't need a calculator. We know we're going to make it bigger by 100 times. So we will move the decimal spot twice. Or if we round it to the nearest tenth, which is common, we would round it to this decimal place here, so we round up. 54.5 would be how long the opposite side would be. Okay, so that's how we solve for a missing side. Now every now and then you'll get a missing side that is missing the hypotenuse, and in that case you might have to cross multiply and have sine or cosine on the bottom. So let's do an example of that. Let's try another measurement. Let's go up here now. 60, let's do 66, because we know 30, 60, 90, we could solve that without trig. So here's my right angle. I'm sorry that it is so crooked. And I'm going to put x as my hypotenuse, and then what I'll do is let me move this over. I'll make the adjacent side 100. So the first thing we do is we pretend we're standing here and we label our hypotenuse. We label opposite of the reference that way, and the leftover one's the adjacent. So in this case, we're going to decide whether to use SO, CA, or TOA, sine, cosine, or tangent ratios. We're using our hypotenuse and we're using our adjacent. Adjacent and hypotenuse are only with cosine. So we're going to take cosine of the angle is going to be the adjacent 100 over x. So your hypotenuse ends up on the bottom, not cosine. So the next step I always recommend is replacing cosine with an actual number. So I'm just going to do exactly what I see on my paper, 66 cosine 4067. And the last step is to cross multiply. So 4067x equals 100. So just like when we have 2 times x equals 100, we would divide by 2 to get x by itself. We're going to divide by the decimal. So we treat it the same way. That's times, so we're going to divide. So decimal. So the final answer is going to be 100 divided by 0.4. So we know it's going to be bigger than 100. When you divide by a decimal, it gets bigger. Divided by 0.4067, and we get 245.88. So 245.88, we would round it to the nearest tenth. That would be this spot. So I'll look here, and it's more than 5, so we're going to round up. That will be our final answer. So the next step is to look at solving for a missing angle. So when you have all the sides, you can have either 2 or all 3. Let's just do, let's make it a bigger number. So let's say I want to find this angle here. So we always label first. Here's my hypotenuse. Here's my reference angle. Opposite of that is here. And next to it or adjacent to it is there. So in this case, when I'm determining whether to use SO, CA, or TOA as a ratio, I'm left with the opposite and the adjacent. I don't have the hypotenuse. So the one with the opposite and the adjacent would be tangent. So we always put tangent of the angle. In this case, the angle's x. So the angle is always going to go in that spot. And it's going to equal the opposite over the adjacent. All right, so here we have an x which is stuck to tangent. In this case, to remove it and make x stand alone, we're going to do the inverse, or the opposite. So the opposite of tangent is to do tangent of -1 to both sides. That cancels out our tangent and leaves x by itself. But it also tells us exactly what to put in the calculator. Rather than put 108 over 44, I'm going to use whatever that is as a decimal. 108 divided by 44 is 2.4545. So we're simply going to enter into our calculator the same thing. And so we're going to use the tangent -1 button, the inverse tangent. So when I take my calculator, I'm going to divide 108 by 44. It's right here. I'm going to push the second button until I see the inverse, or the -1 tangent. And I'm going to push it. I'll get 67.8. So if we're rounding to the nearest whole number, they tend to do that with degrees, we would say 68 degrees. So whenever we have a tangent or a cosine or a sine attached to a variable, like sine of x equals whatever, 0.4, the way we separate it, got our neighbor's dog in on it, we would multiply both sides by the inverse tangent or inverse sine. That cancels this out. So x is by itself. And it tells you that you're going to have to push the inverse button in the calculator. So when we want to separate sine, cosine, or tangent from the variable, we use the inverse button. And one of the reasons for this is the following. Inverse tangent or sine or cosine are using a -1 power. So what we learned was when we have an x to the -1, it's the same as 1 over x. So tangent 1 really is the same as 1 over tangent. So what we're essentially doing here is we're taking tangent of x equals whatever number, 2.4545, and we're multiplying it by 1 over tangent when we do the inverse. Okay, but it looks nice in this case because whenever we divide something by itself, it cancels out. So now x is by itself. But we don't have this on our calculator button. So really, they prefer to use this as tangent negative 1. So tangent of negative 1 is the same as dividing by tangent. That's why it gets rid of the tangent and leaves the variable alone. So whenever you have sine of an angle here, and you have a fraction or a decimal, to separate it, you're going to inverse both sides. Now the variable is isolated and by itself, and we know we have to push the inverse sine button. Hope this helped out. Have a great day.